Now for circular queue, I will discuss the basic idea by taking the example. See, the problem that we are getting here is because we are moving front pointer. Instead of shifting the elements, we are moving front pointer. So if you remember the example I took, the people are standing in the queue. This person is handling a counter, so I have not shown that box. So what we did is, if this person is leaving the queue, instead of shifting all these people forward, what we thought, let us move this person ahead. Okay, so in this way, only one step will be taken and the deletion of a person will be done just in constant time. Only one step will be taken. Now, if one more person is going out, then again he will move just one step. This person will move. This person is moving. So in this way, what is happening is, so in this method, we are getting a lot of free space here. And this space is full. There is no space for a new person. So if a new person wants to join the queue, he cannot join. There is no space here. Now the idea. We will ask this person to come and stand here. This is the back side of the counter. If this is the counter, this person is the front person, counter at the back side. So nobody will stand at the back. Now, if this person says that once I finish with all these people, when I have finished with the last person, again I will come and stand here. Again I will start from this place. If you say that I will be using this space circularly, then people can start forming a queue here also. Yes, that's what the idea is. If the person who is serving, who is handling a counter, he can come back again here. So he can move circularly. So same thing we want to implement here also. Who are inserting and deleting? Front and rear. Let this front and rear move circularly. Once they have reached 6, let them come back again on 0. Then again continue like this. So this is the idea of circular queue. I will take few elements and show you how it is done. Now let us learn about circular queue from the beginning. See, initially front and rear will be at 0. We will not start from -1 now. We will start from 0. So you'll understand why we are starting from 0. Next, using rear we will insert, using front we will delete. So I will insert some element. I will insert one element 10. So rear will move ahead and insert a value 10. So the procedure is same. Yes. What about this location? That location should be left empty. We will not use that location. Wherever front is pointing, that location must be left empty. Let me fill all the elements until this front reaches here. I will fill all the elements. Now queue is full. I have filled all the elements. Rear is at size -1 and front is still at 0. So queue is full. Let me delete few elements. So first element I will delete. So for that, move front to the next location and remove the element. So that element is deleted. I want to delete one more element. So move front to the next location and delete the element. So this element is gone. Now I have free spaces. I want to insert. Can I insert? Yes. Bring rear at 0 and insert the element here. So you can see that a new element is inserted at the back side of front pointer. And you can see that when rear was 6, it became 0. Now I want to insert one more element. This time rear will move in a normal fashion. Rear plus plus, just move one step. Rear will come here and insert the element. So yes, the element is inserted. Can I insert one more element? No. There is a free space. Can't I use? Don't use that space. Wherever front is pointing, that space must be left empty. What happens if I want to use that space? So if you bring rear there, then rear and front both are equal. Rear and front both are equal. Equal means we know the condition. When they are at same place, queue is empty. Let me show you. I will insert one more element, 25. Now front is equal to rear. Is it full or empty? See, actually it is empty condition. So that is the reason we will not use that place wherever front is pointing. So rear is at this place. So if the size of an array is 7, how many elements I have stored? Only 6 elements I have stored. We cannot use all 7 places. Then if I am deleting using front, then I will be deleting all the elements. Then again front also moves like this. So we will implement circular queue over an array by moving front and rear circularly. So array is not circular here. Front and rear are moving circularly. So let me draw a diagram how we usually represent it. I'll show you. So this is how we represent a circular queue. We show array as circular, as array is not circular. Front and rear will move circular. Then how to move front and rear circularly? We want a mechanism such that they automatically move circularly. So what we want, let me show you. When front is on 2, if I say next, it should go on 3, then next means it should go on 4, next means it should go on 5, next means it should go on 6, next means it should come on 0. So I'll be moving next, but after 6 it should come on 0. So circular behavior or the circular values like 0, 1, 2, 3, 4, 5, 6, then again 0 we want. This can be obtained using mod operation. So how we can take the help of mod operation, I will show you. Let us see how mod operation can be used for obtaining circular values. I'll explain it with the help of just rear pointer. Same thing applies on front pointer also. So let us start. Initially rear is 0. So what it gives? 0 plus 1 mod size. Size is 7 as per our example. So the result of this one is 1 mod size. 1 mod size. Mod means remainder. It means when 1 is divided by 7. So it cannot divide. So 7 zeros, remainder is 1. So that number, when it is smaller than 7, that same thing is a remainder. So this is 1. So that 1 is the new value of rear. The next is 1 plus 1 mod 7. So this is 2 mod 7. So the result is 2 only. So that is the new value of rear. Rear is modified. So rear assigned rear plus 1 mod size. So rear is modified. Rear is 2 now. So 2 plus 1 mod size 7. So 2 plus 1 3. So this is 3. It gives 6. From 6 if we say next 6 plus 1 mod size, 7 mod 7, 7 mod 7. If 7 mod 7 means 7 ones 7, remainder is 0. So remainder is 0. So again rear is back on 0. So this statement will give us circular values. From 0 it has started, again reached at 0. So by using mod operator, we will be moving front and rear. So now the previous example what we saw in a queue using array, we will modify NQ and DQ operation and we will modify the movement of front and rear pointer in that one. It becomes a circular queue and it guarantees always the spaces will be reused. So this is the best method of implementing a queue using array. It must be circular. Let us see NQ and DQ functions. I will write the function and explain it. Let us see NQ function, how it works for inserting an element. NQ function takes a Q as a pointer. It's the pointer to a same structure which we have already seen and it is taking a value that to be inserted. Then before insertion I should check whether there is any space or not. Can I insert any value or not? If it is full I cannot insert the element. So I should check for the condition. So I should check for Q full condition. So what is Q full condition? So for explaining Q full condition, I have taken 2 examples here. These are the 2 examples. So let us look at the second example. Here you can see that Q is full. The place where front is pointing is left empty and all other places are filled and rear is here. Now it is full. And this one, front is pointing here, that place is left empty and this portion is full and even this portion is full. So rear is standing just at the back of front. Next location to rear is front only. So what about this? If you see circularly, then what is the next place of rear? After 6 comes 0. So this is also the same situation. So next place of rear is front, then Q is full. So here I am checking that same condition. Rear plus 1 mod size. Rear plus 1 mod size. As because both are in this structure, so I have to write Q's rear and Q's size. Rear plus 1 mod size if it is equal to front. So I am not modifying rear, just calculating that is next place is front. If so, then Q is full. Otherwise, move rear. How to move rear? Rear is modified by rear plus 1 mod size. Then at that same place, Q's rear, value is written. So that's it. This is NQ for circular queue using array. Next we will see DQ. Let us look at DQ operation. DQ function is taking a queue of same type structure which we have already seen earlier, that is queue structure. Then I have taken one variable in which we will be deleting the value. Which condition I should check for deletion? Queue is empty. So what is the QMT condition? Same, front is equals to rear. So initially you saw that when both front and rear were at 0, Q was empty. Front is equals to rear, Q is empty. Here the message is Q is empty. If it is not empty, then I can delete the element. So for deletion, which pointer we use? Front pointer. So I should move front to the next location. And that movement should be circular. So this is the code for circular movement of front. I'll read out. Front is modified with front plus 1 mod size. So Q is coming everywhere because all these are members of a structure. Q's front is equals to Q's front plus 1 mod Q's size. Then from that place, Q's front place, that is Q's front, take the value and then return the value. So that's all about circular Q. We have seen NQ operation as well as DQ operation. And one more thing, both the functions are having just simple statements, so the time for both these functions is constant. So the conclusion is the best method for implementing a queue using array, you should make it circular, then only you can reuse the spaces. Otherwise, the spaces can be useful only once. We cannot reuse them.